I'm applying a new data set with a lot of information similar to exams on the topic of association rule mining. In association rule mining, we've done this multiple times. We try to look at the basket of goods that are similar that people have been selecting. And this can be goods online, services online, or goods offline, or services offline. I used this thing last time. There is a package or a library known as Machine Learning Extender, ML Extend. That is what you use for this. Now let's try to be practical here so that you can appreciate the details of this topic. Have you ever considered the technique behind online recommendation systems or product strategies placement? Have you considered why, whenever you select a particular movie, there are similar movies that are given to you, and you're able to still watch them and keep your subscription going? Because they are able to know what you like and they basket them for you. And sometimes you don't like, but majority of the time, we tend to like the same movies. For example, I don't get comedies because they don't make me think. But somebody likes comedies because they make him laugh. So if you look at this, there's a statement here that said, because you watched New Girl, now you can watch How I Met Your Mother. You can watch Love, you can watch Friends, you can watch Janet, and other things that follow. All because you watched the movie New Girl. This is a recommendation system. And they don't use it on only Netflix. They use it on all the key channels. Even as you know, ShopRite uses a similar one. Temu uses a similar one. eBay, Amazon, all of them they use. So that is the essence of our discussion today. Association rule learning is a rule-based machine learning method. And what you are doing is that you are discovering relations between variables in a large data set. The variables can be so many. In this case, they are movies. The goal is to identify strong connections discovered in the data set using some measures, which we have looked at some, all of them. We use some measures like support, measures like confidence, measures like lift, and so forth. We use those measures to be able to drive home the point. But what is a rule? What is the association rule? The association rule simply says that if you have an expression of X mapping to Y, X and Y are separate item sets. They are separate, like Gary and beans. Now, a more concrete example based on the consumer behavior will be diapers mapping to beer. Suggesting that people who buy diapers are also likely to buy beer. How that connection really works, I don't know. But you want to evaluate whether a person is interested in both items. And to assess the interest in that association rule, to determine whether the association is strong or weak, we use different metrics. Unlike in correlation, where you have to use things like Pearson's product moment correlation coefficient or Spearman product moment correlation. Now, these ones are not numbers, and so they are textual. And because they are textual, there are different metrics that have been developed for that. And what we are going to do today is to use those matrices, including confidence and lift. So you want to be able to use this to understand all the details of what we did the last time. So if a customer buys bread, that percentage value will tell you how much percentage is likely to buy milk. If you see that statement above, and we looked at this last time, but we are taking them one by one. The bread here is antecedent, because that is the thing that has an if associated with it. The milk is a consequence. So if a customer buys bread antecedent, he is 70% likely to buy milk consequent. In other words, it can be understood from this mapping. If you're a retail owner, the association rule is to target those customers who buy bread and buy milk at the same time. And also you position the way you put the milk and the bread together so that the person doesn't go round to get milk when he already has bread. Otherwise, the next time you'll not even buy bread. So this rule of if a customer buys bread, is likely to buy milk, it's a result of a thorough analysis of the data. You have to search through the data, dig into it before you come out with that rule. And it can be used to not only improve customer service, like I've said, but you can also improve the entire profitability of a company. The reason why some people keep some people, see, somebody told me that the price of a Bugatti is $5 million. Why will I go and buy that kind of product? Why? I mean, people are dying in many places. They can't even get food to eat. And you are talking about $5 million of Bugatti. Are you crazy? And I told the person, no. The maker of the Bugatti didn't make it for you. He didn't make the Bugatti for you or your mother or your father. He made the Bugatti specifically for some people who need the Bugatti. And he makes his money anyway, and he makes his profit anyway. Even if 200 people buy that Bugatti, it's worth more than anything. Because he has tailored the customer need. Some people just don't want to use yam. Some want to use yam. So sometimes when a person speaks with a broke mentality, he wants everybody to look like. For example, I was watching this movie where a certain guy is a thief. I think you should watch it. The guy is a thief. He went to steal items from people's cars. And he thought that this particular car was open, so he would sit in it and steal. The moment he got into the car locked by itself. The car is highly classified car. You cannot shoot. The glass will not break. You can't use a metal to break anything. The guy was stuck in the car. And the owner started speaking to him. So the guy was saying that, why would the owner do this, buy this? Why will he spend all of that? And all he needs is $500. So my point is that you tailor certain things for certain people, they are not for certain people. Okay. In addition to the above, the association rule-based learning technique are used in many applications. Like I've said, recommendation systems, medical diagnosis. If a person has got hypertension, the likelihood is that he may also have this or that or that. It's used in protein sequencing. It's used in census data, even in crime prevention. Because that if the person has been here, he is likely to be there and likely to be there. So there are crime areas that people can spot, police can spot. And some of the details are in your work. So when you click here, It will take you to this website, 25 plus real world data mining examples that are transforming industries. You can look at some of them, in your spare moment. They're real application. They are there. Like customer churn prediction. Some of you are doing customer churn prediction in your thesis. It's fantastic for you to go down. Okay. So let's continue. The a priori algorithm that we used last time, it is one of the means by which association rule mining can be executed. Okay. And it basically tells you the finding of the most frequent item set in the data set. Let's identify the most frequent item sets in the data set. And we are going to use this a priori algorithm. We've used it before. We're going to use it. This time, we are dealing with a very large data set. So let's start. You all have this. So you can begin by importing the packages. We've already explained all of these packages. We know NumPy, we know Pandas, we know Plotly, both the graphics and the PX. The transaction encoder, we normally use it for one-hot encoding. The a priori, the association rules, and all the possible graphing. We know this. Hold on. This is not the... Okay, yeah. So you can see that I have the data here. I've already given you the market-based optimization data set. It's a CSV file. You can use that. Don't change the name of the data because that's the same name I'm using here. The data must be in your library, your working directory, for you to be able to use this my command. If you don't have it in your working directory, then you will need a pump to bring the data into it. But if you put it all in one place in your working directory, you're good to go. So you want to load that data and then look at the shape of the data. What do we mean by the shape of the data? The shape of the data is basically the number of rows and the number of columns. That's all. The number of rows and the number of columns. So load these data sets and let's get going. So run this command, and as you can see, I have this result. That means that there are 7,501 rows and 20. Most of you who are doing your work and your long essay, I beg you, get more data. This is going to punish you if you don't have a lot of data. So please try and collect the data now because you'll be behind. Next semester, you'll be learning about machine learning, supervised machine learning. All that we've been doing is unsupervised. But most of you, the nature of your work, and that's where I like that. This one, I don't know, I don't like it that much. But supervised machine learning is the real deal. And that's where we'll do the practicality. It will help you a lot in your long essay as well. But then sometimes, occasionally, you need unsupervised techniques like k-means algorithm, like association rules mining, to be able to, depending on the work you're doing. Now you can look at the head of the data set, the first 5 rows of the data set. And you will notice that, okay, so you run this, okay, run this, and it will give you the head of the data set. Okay, so you have all of it here. So the data set, this is 7,500. So the data set has got quite a number of items here. Look at them, 19 different kind of items. It's got that here. Some of them are shrimps, almonds, avocado, vegetables, green grapes, whole wheat, yams, cottage cheese, energy drink, tomatoes, juice, low-fat yogurt, green tea, honey, salad, mineral water. Mineral water is an interesting guy, so watch it very soon. Salmon. Many people might not take it because it's expensive. Antioxidant juice, frozen smoothie, spinach, olive oil, and so forth. So these are the various items that you have. Now, so you can have a look, and then you can describe the data. So let's have a bit of description of the data. Run this, and let's describe it. You will do this in your longest here as well. So this gives you a description of the data sets. Now check it carefully, and you see something is even wrong here. First thing is that you will notice that the count of the variables are different. Okay, the highest is here. That's the first one in column 0. But you will also know that as you go down, they keep reducing up to the 19. You also notice the uniqueness, the number of observations, uniqueness there, the top items that you see there. Okay, mineral water appears consistently, 577, times it appears, and olive oil appears only once. So there's something about the data we want to clean. Okay, but first, note some few things about the data. I can ask you to type data 1, okay, where data 1 here will give you the second item. The second item. If I ask you to, so let's do data 1, then you see what I mean by second item. I'm just removing this, and then run data 1, okay? So it will give you the second item there. And the second item here is talking about the second sort of column of information that you have. That is data 1. If I wanted data 0, it will give me only the first one. So for example, if I change this one to 0, guess what? Okay. It gives me the different sort of items there. Another thing you can check is the data shape. The data shape. The data shape will give you a tuple, and I'm sure you guys have learned about tuple, which will tell you the dimensions of the array of the data. So if I mute this one, the first one, and I just request for that, okay, for the data shape of 0, it will tell me the number of rows I get for that 0. If I change it for this, I'm going to get the same thing if the same thing is there. So let's say 1. Okay, it tells me that, 20 items are there for that particular dimension. And if I do for 3, okay, let's do 19. Okay. Let's do for 10. Okay. Because it's just giving me the key. So it means that the key items I'll get there are just few. Okay. It's just few items I'll get there, like shape 1 and 2, or 0 and 1. And then you can also do for values. Yeah, I think the values is what I was trying to do. You do for values. Let me remove this one and mute that, and then run for values. That will give you the location of that particular row and column. So if I do value for this, it will tell me for Courtney, the location. So the 2 here means that it is on the 3rd row. Remember, it starts always from 0, 1, and 2. So 2 means that this particular Courtney is on the 3rd row in the first column. The 3rd row in the first column. If I want something in the 3rd row in the 3rd column, it tells me that it's none. So that particular item is not there. And the 3rd row in the 2nd column, okay, that is also none. Okay. And the 3rd row in the 1st column, okay, that one is Courtney, which is the one we started with. So you can actually pick some of these, but the data is not clean. So the first thing you want to do is to clean the data. Okay. So to clean the data, you need to gather all the items of each transaction into a NumPy array. The transactions here are assumed to be the list of items. Okay, we've done this multiple times. We can use this command to gather all of that, to gather all of the items in one. Then we can now tell Jupyter Notebook or Python, that I want you to put them in a NumPy array. So what it's going to do is that you're going to create a nesting of the loop, and that will iterate row by row and then column by column. All of the items will be flattened into one long list and then converted into a NumPy array. In short, what this code is going to do is that it's going to transform the transaction level data into an item frequency. So you're going to see the results that it will be an item frequency. And this is very, very basic step when you want to compute things like support, when you want to build association rules, okay, and so forth in the marketplaces. I've given you all the information here. The next step after the transaction of the NumPy array is to transform them into pandas data frame. In other words, you are trying to ask the question, which is how often does each item occur across all transactions? Now, somebody might say that, but how can I do this thing when I'm doing my own long essay? Okay, how will I know these codes? You will know these codes by learning from what you are learning here. You know that. So how do you go about the transformation process? First, you create a DF data, which is a pandas data frame, and then you can now indicate an incident count. This will create a counting column. Okay, every row will get a value of 1, meaning that this row is telling you that there's one occurrence of that particular item. Okay, it's a trick. It's a standard trick that is used for frequency counting via aggregation. So you do that, and then you show this, and then you get that. You get the results. I'm putting all of these codes together. I can cut this, okay, for you to see what that one would have given us. Okay, that's what it's giving us here. All right, now, after that, you have an index, because right now, it's not using the indexing, as you can see. So you're going to create an index of the names. You know, you tell the app to find rows where the item is a string. Because when it is a string, and it has a string of none, N-A-N, it means that it's not having any value. Okay, so NP none is different from none. Okay, NP none, NP.none actually means missing value. Okay, so this point I had to make it clear. NP.none is missing value, but none is actually a string value. So take note. So what we are doing is that we are only removing the literal non-text entries. Not that it's because it's a missing value. And then we will now drop the index. So this will remove the rows containing the none from the data set. Every row that contains the none is going to be dropped. The idea here is to clean the transactions before you do any analysis. And then you can now group item, and then you sum the count and then sort by frequency and then reset the entire data set. That is what this command is going to do. And then this last command here will create a column. Okay, you have one column and you're going to see that below. Okay, every row will contain the word all. You know, it will do that. It will prepare the data for pivot tables. You can use it later for heat maps. We shall look at that. And then for the association rule visualizations. So this particular command here is allowing you to use this thing later for further work. And then you can now generate the table. So all that we are doing here is that we are asking the question, how often does each item occur across all transactions? And this is something like a beginning stage, you know, before you apply the apiary algorithm. It's a beginning stage. It's sometimes what you got to do first before you do even item popularity analysis, before you do which item is being popular, is frequent, you still need this one. So let's run this and see the results. And now you get the results exactly as we want, okay? So you have all of the information of the data. It's 120 rows, 3 columns, okay? You can see the number of times a particular item is appearing. So for example, asparagus, which is very, very green, appears once. Water spray appears 3 times. Mineral water appears over 1,007 times. You're able to see all of these details. So what is this doing? The pipeline you just seen here is that, first of all, we have flattened the transaction matrix into a single item occurrence vector. Okay? We have constructed an incident matrix, as you can see in the second column, so that it will count the frequencies, and you see the frequency in the third column. Yeah. And then we have also removed missing observations, and we have combined the occurrences to get global support measures before the association will come. So you can see how many times any of them is appearing. Now, we can gather all the items of each transaction into NumPy, go through the process again, and then this is the key part here. Transform them into a pandas data frame. Okay, so you put 1 to each item for making the table count, and then transform the entire group. You delete those that are NaN, none, and drop those that are. In fact, look at this, because I've explained this something here for you to see. You see this item here, okay? Anything that is not available or has a missing availability, any item, you are going to delete them. And then you're going to create a new pandas data frame ready. You're going to make it ready for visualization. This command will also do that. And then we can now have an initial visualization of that. I'm using the word blues, but I can use any map, any color. And sometimes when you want to verify any other color, you can just use any other color to see. And this is just going to give you each item and then the frequencies. Each item and the frequency. The color alone gives you the depth of the frequency. Let me see if we can change this to reds or greens. Yes. So if you change it to greens, you can have them in greens, and it just shows the depth of that particular item, the number of occurrences or frequencies. And you can see that mineral water is really, really doing well. It's occurring multiple times. Okay. Now, I have indicated that I wanted only the first 10 rows. So if you want just 5, you can run that for just 5. Okay. You just have that. If you want for that, you can have it. So you can have as many of them, depending on which one that you're looking for. You can change it. And then you can see the extent of, so as an initial check, you can see that a lot of people are taking mineral water. A lot of them are taking mineral water. A lot of them are taking, people are buying eggs a lot. They don't joke with their eggs at home and things like that. Majority of the people are doing that. It's not everybody. Yes? It's not everybody who will be buying olive oil, but they'll be buying. Okay, so this one, I'm going back to the top 10, and then we'll comment on the top 10. If this is generated for you in an exam, what are some of the things you can say about it? So the top 10 table shows the top 10 most frequently occurring items across all transactions. And the second column there is the number of times each product appears across transactions, and is heavily, effectively an item frequency table. And that is what you use to also handle your count. So let's try to interpret one of them. Mineral water, it has 1,788. What does that mean? It means that mineral water is the most frequently bought item in the data set. It appears 1,788 transactions in the whole 7,000 and over, suggesting that people are habitual buyers, of mineral water. Okay. What it also means is that mineral water likely appears across many baskets. So as people are living with their trolleys, they have mineral water of some sort in their trolleys. It doesn't matter what other items they buy, mineral water is there. And when you use the algorithm of apiary, okay, in such language, we can say that it's going to have a very high support because it is occurring most of the time. But it's not necessarily high confidence or high lift. Okay. Because, for example, everybody will go and buy water, but not everybody will go and buy diamond. Okay. Diamond is something that many people would want to have, but not everybody will have confidence. You have more confidence. If somebody dashes you diamond, you're going to be so glad because it's a luxurious good. But if somebody dashes you water, water is a necessity, you know, and that's what we call the Giffen paradox. All right, so that is for mineral water. Then you have another thing like ground beef, the last three. Ground beef, you see the color there, they are all of the same color. Ground beef, frozen vegetables, pancakes. Okay, what did you see there? They all have lower frequency compared to the top items. But they are still important. It doesn't mean they are not important because we selected only the top 10. Okay. So what this means is that possibly people buy them when they need them. There are specific items people normally buy when the need arises. It's not about mineral water. Mineral water is something you buy. It's not when the need arises. We always need it. Okay. And you can see that these 8 to 10 variables, they appear strongly in the combination rules, not alone. They are not on their own. So they are kind of brought together with other things. Okay, these items are often more informative or they give a lot of a priori knowledge because they are not always bought and they can produce higher lift. So the summary of the information you are seeing up here, what you can say about it, if it was an exam context, okay, is this, that a frequency distribution shows that mineral water, eggs, and spaghetti are the most commonly bought items, reflecting staple consumption patterns for these. While the mid-frequency items like ground beef and pancakes are more likely to generate informative association rules because of their conditional purchase behavior. So that is what one can say regarding this. But now, what are the most demanded items in the data set? What are the top 30? Well, we're going to do some things here. We're going to calculate that. And to do that, there are some few things you would take note of. The word all and then items, I've already explained that it talks about a hierarchy. Okay, all here is all the individual items. In the command down here, you're going to see values of incident count. The value of the incident count, if you get a rectangular shape, okay, that particular one that is dominated is going to have a very big rectangle with a frequency also in it. And you see that very soon. We are going to choose a color, okay, and the color intensity will tell you the frequency in which people are buying that thing. We are also going to display the item name on the hover. That is what this command would do. And you have that same command down here. Okay. And then finally, we are going to use blues, darker blues. The more darker blue it is, the higher the frequency pitches of that particular item. And like I said, you can use other things. So we're going to show this result from that documentation. And this is important because this is something you can plot into your actual work. So this is it. In fact, you can just click on this and just move it. Why is no? When you look at it, it will tell you some things about it. When you hover the cursor on it, it will tell you the values. You know, it will tell you what the item is, the values. It will give you some kind of picturesque understanding. of what it is. And you can see that salmon is at the bottom somewhere. It's not being used at all. Okay. Now, if you want to know the numbers, you have to scroll through. You have to, but you can also drag. I just put my hand on it. Okay. I just click on it. Okay. It will expand. Whichever one you want to talk about it. Okay. If you click, so if I click on mineral water, it will expand mineral water for me. If I click again, it will take it off. If I click soup, it will expand soup for me. Okay. And then on and on, you can do any one of them. So what does this mean? What we've generated here, this rectangular, area frequency, what does it mean? Well, larger rectangles will mean that the items is appearing more frequently. Smaller rectangles will tell you that the item is not appearing more frequently, as you can see for honey and salmon. And you can see that here, mineral water occupies the largest area. Pancakes and frozen vegetables are around the smaller area. Where is pancake? Okay, so there are more down there that you can have actually. Pancakes and frozen vegetables. There you go. No. This one is frozen smoothie. There you go. Frozen vegetables, pancakes, they are smaller, relatively speaking, compared to mineral water. And then I've also indicated that the dark blue, okay, for mineral water shows you that it has a very high incident count. Light means that it has a very low incident count. So how would you interpret this briefly, in an association rule mining with all the knowledge that you have? You simply say that each box is an item. Bigger and darker boxes mean the item appears more often. Now, if I should, let me see whether I can use black. I don't know whether that will work though, but let me see. Yeah. I knew it will not work. Okay. Because if your assignment is not printed, let me say gray. Grace. Yes. Grace is better because if your exam is printed, it's not going to be printed colored for you. It's printed black and white. So when I use this one, gray, it gives you a clearer understanding of how yours is going to look like. Okay. So I just use grace and then you get it. You can experiment with some of these other ones. All right. So what it means is that bigger and darker boxes mean the item appears more often. Everything starts from one root called all. So we can compare items on the same scale. So that is why we are able to do the comparison. And you can see if we are told to pick the smallest, in this very example, the smallest, frequently observed items, the top three smallest. What would be your top three smallest? What would be your top three smallest? Be careful. You can tell me the top three smallest. Yes, Falake.
So please, I think it's salmon and fresh bread and champagne.
Salmon and what?
Fresh bread and champagne.
Okay. Salmon, fresh bread, and champagne. It looks true, but one of them two might be questionable. The champagne. Why? Why might it be questionable? Do you realize it? Go and find out why champagne might be questionable. I mean, the rest are fine. Why champagne might be questionable? Especially when you look at one of the things above it. Okay, so let's check whether the items have multiple records in a transaction or not, a particular item. Let's say that that item has multiple records. If it is yes, we need to handle that item since they might mislead the algorithm that we are going to use. So how do you check whether a particular item have got multiple records? Well, first thing is that you got to transform every transaction to a separate list and gather them into a NumPy array. And that way, you'll be able to iterate through array of transactions anytime you want. So this code will do all of that work for you. It also picks the top 20. Please, just a second. All right. So when you run this command, you're going to get the same thing that we had before, but you can see that we have used numbers instead of what we did. We have used numbers on them. Run this. So you can see clearly that the number of times, for example, mineral water is appearing. If it is a yes, it's a 1. If it is a no, it's a 0. And then the other ones you can see. Okay. So this graph tells you something. I mean, this table tells you something. The multiple record, check. It will confirm whether a particular item, is frequent and it's appearing more than once than, other transactions are doing. So you later use this one to validate the work. But remember that these ones are binary items, which is very good to use because of the one-hot encoding that is sometimes needed. Okay, so this table shows whether, if you ask a question on what does this table show, it shows whether people buy the same product twice in one shopping trip. If most values are 0 or 1, that is what is going to help us to do our apiary assumptions. Why is this thing not showing here? Okay, let me just refresh it. This is just okay. Okay. All right. So this command here is DF top 20 multiple records. So those that have top 20 multiple records, you're going to show it. Okay. You just want to find the descriptive statistics of those items. Okay. So look at it here. When you run this command, the reason why I like this is because those items, the count for all of them is the same. Okay. You can see the count for them are all 7,501. So that's the first thing. That's the frequency. Their means are also shown here. Their means are shown. And check carefully. You will notice that the means are moving downwards. Okay. So for mineral water, the average is for mineral water, the average is 24%. For eggs, it is 18%. For spaghetti, is 17%. And it keeps happening like that, like that. And you can also see the standard deviation. Guys, put this down. Anytime the standard deviation is bigger than the mean, it shows a lot of variability in the data set. Let's say that you want to measure weight of some children, and you check the average weight is, say, 2.5 kilograms, and you check the average standard deviation, it is 5 kilograms. That is dangerous. That is dangerous, because what that means is that there are some of the kids that are too big, and there are some of the kids that are also too small. There's a question on this in your exam. That's why I'm explaining it. Okay. So anytime the mean is smaller than the standard deviation, anytime the standard deviation is bigger than the mean, it shows a lot of variability in the data set. Okay. And you have the minimum value and the maximum. This is the maximum value I'm interested in. So I want you to watch the maximum value carefully. Do you realize that one item has got, most of them have got a maximum value of 1, but one particular item does not have a maximum value of 1. Which item is that?
Chocolate.
Chocolate. Okay. Anyway, most of the things I said before, they are all written here. That each column, I'll come to the chocolate one, don't worry. Each column is one of the top 20 items. Every column has 7,502 observations, no missing rows. Okay, you said that. On average, mineral water appears 23.8% of the transactions, eggs 18%, pancakes 9%, and then it goes on and on. Because values are mostly 0 or 1, the mean is equal to the support. Okay, this point is important because most of the values are between 0 and 1. And so everything else you're dealing with is going to get between 0 and 1. And therefore, the mean will average the support. And that means that the mean becomes the probability that an item appears in the transaction. That's what I mean. Because the probability is anything that is between 0 and 1. Okay. And then I also spoke about the standard deviation. Okay. This is the same thing. I said that items are not bought in quantities, they are bought or not bought. So the fact that you have the standard deviation being bigger, the standard deviation for water, for example, is 42%. Normally, when you have a standard deviation, technically, when you have a standard deviation, that is between 0 and 1 for a binary classification like this. It is meaningless, but it's giving you a standard deviation. For example, when I tell you that, give me the mean for male and female, and I have male there, I have female there. I didn't say their ages, so I said I have male. So if somebody is a male, it's 1. If somebody is a female, it's 0, 1, 0, 1, 0, 0, 0, 0, 0, 1, 1, 1, 1. And I tell you to tell me the mean. When you tell me the mean, and the mean is a particular number, it means nothing, technically. Suppose the mean is 0.48. What does that mean? You can't explain, because this is a categorical variable. Okay, and that's the same principle here. Now let's come to the point I wanted to say about the chocolate. Chocolate has got a maximum value of 2. What that means is that chocolate occasionally appears twice. In other words, people are doing what is known as bulk purchase. All the others have a value of 1. So from that reason, we can say that the data is homogeneous, generally, because all of them are got. We can proceed without any inference. In other words, we can continue and do our association rule mining. The data is effectively binary, just as we wanted it to be binary. It's only chocolate that is having 2. The rest are all having a maximum of 1. Okay, and then of course, as you can see, a minimum of 0. When you check the minimum, you see that one there. It's also 0. So we're in a binary setting, and that will validate any a priori score or particular analysis that we shall do. So the key takeaway from this descriptive statistics is that the table proves that our shopping baskets are binary. Basically, they are not quantity-based, which is exactly what the a priori analysis is looking for. It's looking for a binary situation. Very good. So now we can go to our choice analysis. Let's look at customers' first choices. Okay, and to do that, we're going to go through the same thing again. Okay, just do some few changes. We gather only the first choice of each transaction into an array. And then just like the above, we do all of that. But the key point is that we'll generate a final step, which will make a new appropriate pandas for visualization, aggregate a first choice, add a hierarchy to the label. Let's see how that works. And then, of course, I need to combine that one with this command. But just this part here alone, it tells you that we're only looking at the first item in each shopping basket. So it's telling you what the customers came for, not everything they ended up buying, but what they came for. And we are able to use this to identify the main reason for the shopping trip. By isolating the first item in each transaction, we can capture customers' primary buying intentions. Okay, so let's run and see the result for this. You get this beautiful graph. Watch it very carefully. Some of them are close to the word food. Food is the main thing. Some of them are close to the word food. Some of them are far away from the word food. Okay, we're going to interpret all of that. So what does this network diagram show? Food is a central root node. Okay, every other thing is connected to this node, which is the first choice item. Now, this is not association rule network. Okay, there are no links. That's why we say no association, no links. There are no links between the food. It is simply a first choice or a trigger structure. Just a second, please. All right, let's continue. So customers come to the store primarily for food, but with different entry points. Each outer node that you see there, like eggs, ground beef, shrimp, spaghetti, you can see some of them. Those that are on the outer node, they will represent an item. For example, you can have an item that likely motivates the shopping trip and act as a basket starter. So basically, the picture you're seeing here, it is showing you the product that start a shopping trip. Every line will tell customers often begin their shopping with that item. So a particular customer will begin shopping chocolate first. Another customer will start shopping mineral water. Each line is telling you, they are not just popular items. They are just the reason people come to the store. That's all. That's all. Now, that's the first choices, the reason why they come to the store. Second choices, okay, you can run this command again and follow it through with this. It will now give you the things they buy when they have bought those things, okay? The things they buy when they have bought those things. So, this particular example will tell you, as you can see from here, you can see that they are quite similar today, but I've just taken the top 15 second choices. Okay. So you look at the second choices item customers put in their basket. Okay, it's going to bring out what people usually will add after they've added their main purchase. That's what they do. The main purchase was the first one we did. And these items are often complement or impulse buying. So they didn't really come to buy those items. Okay, they just went and bought something else. And by the time you realize they bought these particular items. And when you are able to detect that, you are also able to use those things to bring them closer. So you are able to see clearly, okay, these are the things people are buying. Okay, so these other items, it is over time. We've considered them consistently over time, and we know that people normally come to buy these as their second options. And so they capture what is known as sequential purchase behavior, revealing complementary and impulse-driven additions that follow the original one that the customer chose. Then we go to the third choice. I'll show that one, but I just want to talk about it. The third item in the basket will tell you what a customer had once they already know what they are looking for or buying. Okay, they are usually complement or also impulse buying item, not the main one as before. And then you can go fourth choice, fifth choice, and things like that. So you can run this and see the customer third choices. Here we are using a different graph to indicate it. So these very choices, okay, tell you what customers usually add as their third choice. And you can see that these products are not why they came to be there. Now, even though mineral water is also here, what it means is that mineral water is somebody's third choice. That's what it means. But whatever it is, mineral water consistently to be a first choice, a second choice, and a third choice. It might not be somebody's first choice, but it must be a third choice. And so when you're counting the third choices, mineral water still what? Still appears in the third choices. You can have it all the time. Multiple ways of having that. Of course, you can run it together and see the real. So you should be running whilst I'm running. Okay, so all of these are preliminaries. Okay, now we want to use the a priori algorithm and all the other frequent item sets. Okay, we are going to transform the data into a 0-1 matrix where rows and transactions are columns and products. In that particular matrix, we are going to use 1, if the product has been bought on that particular transaction, or 0 to encode if the product has not been bought on that particular transaction. This is something known as data pre-processing stage, and it is required if you want to do a priori algorithm and association rule mining. In fact, it's just like when you're doing basic regression and you have to do things like correlations, scatter plots, and things like that before you come to the real regression. Okay, there's a link here. There's a link here that you can check later that shows how, data pre-processing is done. It will help you also, not only in this work, but also in your long essay. All right, so how do we go about it? The first thing is to transform every transaction to a separate list and gather them into a NumPy array. Okay, so when you do that, around this one, and when you do that, gives you this particular array. So you have all of this array. We are processing the data. The next thing is to do transaction encoder. We've done it. Bring it into a 0-1 situation. 0-1 is basically bringing it into a true or false. So this command would just generate a true or false for each of the item sets, all the 7,501 rows. Okay. So some of them are false, some of them are true, as you can see here. The next thing to do is to find the shape of the data. And when you did the shape of the data, you can see that we have what? 121 columns or features. So that's a lot, eh? So we need to extract the most frequent one from the 121. To actually use that will be very compelling. So we can just stick to the top 50. Top 50, which already has illustrated in section 3. All right. So you have to cut the search space by more than 90% while preserving the most informative item. In short, what we are going to do is to just have 50 items instead of the 120 items. Selecting the top 50 is best because it balances computational efficiency. It allows you to interpret that you don't need all of them. The April algorithm, will tell you that frequent and infrequent items, those that can be generated and those that cannot be generated. So 50 is not a crime at all. 50 is fine. So we are now going to create a command to restrict ourselves to the 50. 50 different, combinations. So we just generate this command and select the top 50 by saying head 50. And then we show the data set for the top 50 columns, so the top 50 columns, instead of going right to it. They will all have the same rows. So now we don't have 121 columns, but we rather have 50 columns. It will still have its own false, true or false. We can extract the first 50 columns successfully using this command. So these are all the 50. If you count them, you see that they are all 50. These are different items. Okay, different item sets. So when you go to one particular shop, there are a lot of things in there, basically. Then we can now convert it to 0 and 1, as you know, because even though we have done it here, it looks true or false. And true or false is not enough. We just have to use 1 or 0. Just a second. All right, you use 1 or 0 in that regard. Then you run the command. So this command will show you just the first head of the data set for each of these. So as an example, asparagus, okay, the number of times it appears in this particular item set, 0 or 1, you see them there. So that completes the entire data processing. Now you have your 0 or 1, and April algorithm can now be implemented beautifully. How do you do that? Well, remember what that algorithm does. The algorithm will help you calculate, the frequency of the variable, and then use some matrices or metrics that will help you to know whether the association is strong or weak or what. And one of the metrics to use is the support. Just to remind you of what support is. Support is an indication of how frequently the item set appear in the data set. That's support. In other words, it tells you how popular an item set is in the data set. And this is a formula. We've looked at this already, but this is just a recapitulation. So how frequently the item set appears in the data set. That's support. Confidence tells you how often the rule has been found to be true. Because that's what leads to confidence or no confidence. Okay. A confidence says that how likely item Y is purchased when item X is purchased. If I buy Y, will I buy X? That is confidence. What about lift? Lift measures the ratio. If you can remember, we used to say that one talks about the association, the other talks about the causality. Okay, it looks at the ratio of Y and X. Okay, how they occur together with the ratio of Y and X occurrence. If they were statistically independent with each other or they were statistically dependent. So another way of talking about lift is that it tells you how likely item Y is purchased when item X is purchased, while controlling, that part is very important, while controlling for how popular item Y is. If you have a lift score, that is why we say it only tells you association. It doesn't tell you causality. A lift score of 1 indicates that the antecedent, the one that started, and the consequent are independent, and they occur, or the occurrence of the antecedent does not affect the occurrence of the confidence. But if you have bigger than one, it shows you that the one that comes first, let's say X comes first, okay, and the consequent Y comes second, they depend on each other, okay, and therefore the occurrence of the X, the antecedent, has a positive effect on the occurrence of the Y. And then a lift score of lower than 1 tells you that, it has a negative effect on the consequence. So the value of the lift we are about to calculate will tell you what exactly is happening. So having a lift bigger than 1 is critical. It's critical to prove association because it shows clearly that there is a positive association. Then there is a convection. The implication strength of the rule. We are now speaking from statistical independence. It is a score value. It's between 0 and infinity. What does that mean? What does a score value of convection? What does it mean? First of all, it's the ratio between the probability that X occurs without Y while they were dependent and the actual probability of X existence without Y. But let's take, for example, if you have French fries, okay, and French fries maps to beer association, and this association has a convection score of 1.8. What does that mean? The rule will be wrong, 1.8 times as often, in other words, take the upper value, the 8, okay? So 80% more often if the association between the two were totally independent. That is what it means. We'll look at that with some of the items that we're about to see. And then that's what this I've explained. I will not even talk about the consequent and antecedent. We know what they are. Okay, so we're going to interpret or explain those things, apply them to our own. We're going to implement the work here using the ML extend, and it's going to give us all the things that we need. Okay, we'll use that particular one to generate a lot of them. But first thing we want to do is to extract the most frequent items and then the length column. So we already know this. We are just extracting the most frequent item, which is the support, and then the length. If you run that, let's hold on, it's loading. I hope I ran the ML extend before. It's still loading. That is why you still see the X. It's taking some time. Okay, there you go. So you can see this command actually shows, all of those particular ones that I used. Okay, the minimum support I gave was 0.01 or 1% because I just don't want too many ones below. So those with a minimum support of 0.01, I don't want them. So what do I get? You get the particular items and those, and many times, how many times they appear? Those that appear individually, okay, like almonds, you see the support value. Okay, like avocado, you see the support value. Those that appeared 4 times, okay, in the basket. So you can see that mineral water is appearing here. Mineral water is appearing there. Mineral water is appearing there. Mineral water is appearing with other items consistently. Okay, and I'm sure that, well, it happens that a person will go to the shop and just buy mineral water and that's it. But this is the result that you get. You can also get portions of the result. Okay, you can say that I want you to just give me the item sets that have a length of only 2. And in addition, the support must be bigger than or equal to 5%. Okay, I just want that. So it's going to pick this. When you run that, you're going to get this. It's going to give you only those that have what? Support of 0.05 and above, and also have a length or count of 2. And what are they? They are eggs, mineral water, spaghetti, mineral water, chocolate, mineral water. And again, that tells you how mineral water is really displayed. Or you can say that I want items that gives only 3 frequency. Okay, only 3 frequency item sets. In other words, the item sets, the items in the basket are only 3 and not 2. And again, 3, this one I didn't talk about even their support. Okay, it's going to give me all of them, those that have 3. Okay, and you can see spaghetti is there, mineral water 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 is there. Okay, it's appearing itself in most of them. Of course, the support is going to be slightly weaker because we are getting to, heavier items, like we are increasing the length in that. And then we can also extract other things, it can be specific and extract other things. But the most key is that we can create our rule now. We can create our rule. We can define the metric and the threshold for everything, all the rules. And I think the last time we went through a similar one. So we are going to set our metric as left. Okay, we're going to define whether antecedents and consequences are dependent or not. That's the first one. The threshold, okay, is selected as 1.2 because it's required to have a left score of above 1 if there's a dependency. Okay, so we're going to set up this, and that is what we've done. Okay, so this 1.2 is a threshold, the minimum threshold. And we are setting it up for the number of item sets to be 1. And because we've set it up to 1.2, it means that we are not going to get too many. We're just limiting the dependency ratio. And then we want to sort out, this command says we want to sort out in an ascending order, but we are not doing that. So it can arrange itself in every possible ways. So this is the result you get. And the result will give you everything that we did last time. You get the antecedent and you get a consequence of the item. And you get a support, you get a consequent support, you get a support and you get a confidence. Now remember, you have the antecedent support and the consequent support on their own before you have the support for both of them. And then you have the confidence, you have the left, you have the representativity, leverage, conviction, Zhang metrics, Jacquard, all of these things. We looked at most of them the last time, and the certainty and the Kaczynski. Okay, all of that. You have this. So what is this? What does this mean? This is the most important aspect of the association rule. What do all this imply? So if you look at the data above, guys, you can clearly see that the dependency ratio between herb and pepper, the first one here. Look at the dependency ratio. Okay. What does that tell you? Herb and pepper and then ground beef is very high, and you can see the lit score is 3.29. And you will also notice that it's approximately 2.5 times of the threshold. The confidence score is promising 32%. Okay. That's it here, 32%, which is very, very good. So just picking on herb, I mean, you can pick on any one of them, okay? So you can pick on that and see that the connection between herb and pepper Okay, these are two items, and ground beef, one item, is very, very high. The connection between them is very high. In other words, when a person buys herb and pepper, okay, what are you going to use it for, basically? What are you going to? You're going to use this one to prepare your beef and eventually have some wonderful taste in that. You can get similar insight, of the data set. And the one way you can do that is by looking at the confidence. So let's go down and look at the confidence. This time, sort the values based on the confidence. So if you look at the confidence here, the confidence is coming down. That's what I mean. First confidence is 50.6%, 50.3%, 47. So the confidence are going down. So you are sorting the values based on the confidence. And what does that tell you? So again, from this table, the customers who bought eggs and ground beef, and you can see that as the first one, eggs and ground beef. Okay, look at their confidence value. It's more than 50%. Okay. It's expected to buy mineral water with a likelihood of 50% confidence. We saw that there. The lift and the conviction score support that hypothesis too. The lift is above 1. Okay. The conviction score is above 1. So they all support the fact that customers who go with this, with the mineral water, will actually go same. So when you are shelving them, when you are putting shelves on them, eggs, ground beef, mineral water should not be far away from each other. Okay. It will be better to keep them close to increase sales if you want to increase sales. And because the most demanded product is mineral water here, the association results are mainly dominated by mineral water, if you check it. So one thing you got to do as an owner of a shop is to get more insight about this mineral water. It's better to create a confidence table, get more insight about mineral water on its own, and then create a confidence table without it and see what is the next thing that people are actually dancing to. And one way you can do that is by setting this command here. Create this string variable to indicate that you want consequent and mineral water, and you want antecedent with mineral water, and then sort the value by confidence once again. Okay, so you can see that for each one here, mineral water has been excluded from the above, so there's no mineral water there. We can say that there is a significant relationship between ground beef and spaghetti, red wine and spaghetti. Okay, and the lift and the conviction scores also support that. I'm just picking the first one, ground beef and spaghetti. Okay, confidence is high. The lift is high, as you can see, 2.29, and then the conviction is also above 1. All of them are above 1. Okay. So ground beef is on the top in both mineral water. Anytime mineral water is included and excluded in the table, ground beef is coming. So for that reason, to catch new associations related to ground beef and boost the sales, you can look into the associations where ground beef is the antecedent, rather. And you can run it here where ground beef becomes an antecedent, as you can see here. And then what do you observe here? Again, taking just the first one, okay, with mineral water, there are many associations with high confidence and lift scores, So you can see all of this. If you check the confidence, you can see it. If you check the conviction, they are all above 1. Okay. If you check the lift, they are all above 1. That's the point we are saying. So what is the conclusion here? From all of this investigation, the flexibility of the algorithm and then the package we have used is high. You can see it. Therefore, we can easily investigate different aspects, different aspects and get new associations from the data. The investigation could be further detailed by taking other products, maybe the rest of the top 50 instead of the first top 50, because there were 120, and calculate and change the criteria threshold like we did. However, because association rule learning has an iterative schema, You need to understand the data and interpretation skill. You need to have some skills and activities before you stay. You can't just look at it and just make. You need to have a feel of the data before you can actually proceed. So if the data is not clean, you have to clean it. Okay. So sometimes if you know the industry that you are dealing with is good. If you don't know the industry, maybe. I mean, this is food industry, so we are all good at the items there. We should give enough importance to data visualization because data visualization can help you. We need to do a lot of cleaning of the data, to be sure that we are on the right track in that. So the last time what I did is I posted some papers on association rules. Some of them have used all that we've done here. So you can look at them and it will open your mind regarding it. Now, what is the take-home point that I want you to have? You should be able to read the support, the confidence, the lift, the conviction of the data. For both antecedent and then that of the consequent, you should be able to read through these very key metrics. And once you are able to read the key metrics, understand them, know the threshold, know when it is bigger than 1, what does it mean? When it's lower than 1, what does it mean? When it is the same as 1, what does it mean? Once you get that, this last table, once you get that, that is the main thing for this. Ladies and gentlemen, that brings us to the end of the entire capital. Some of you were mentioning exams. How will it take? How will it look like? So what we're doing is I'm getting you a mock exam, not a mock exam. I'm getting you an exam script for you to have a look at, to prepare yourself for it. But please note that a part of the exam will also include a similar thing you did with a computer. So part of it will be, the other part will be a paper that you write. I'll give you more of the details when we have come together as lecturers and we fully decided. I'll give you more details in January. So ladies and gentlemen, that brings us to the end of the entire capital. If you have a question, please, you may ask now.